Hi guys, welcome back. So this time we are going to learn about fundamental counting principle. And since I want you to appreciate fundamental counting principle, so let's start with this simple example. Claire has two shirts and two skirts of different colors in her closet. The colors of the shirts are pink and black, as you can see in the figures below, while the colors of the skirt are black and white. She wore one of the combinations, which were a pink shirt and a white skirt. What do you think are the other possible combinations she could try? And to find other combinations of shirts and skirts that Claire could have worn that day, let's do this illustration through what we so-called tree diagram. So let's assume Claire chose a pink shirt. And choosing a pink shirt, she could pair it up with a skirt, a white skirt, and a black. That gives us two combinations already. A pink shirt and a white skirt, and then a pink shirt and a black skirt. So this is one. This is counted as one. This is counted another as one. Now, what if Claire chose a black shirt? If she chose a black shirt, she could pair it up with a white skirt or a black skirt. And that gives us another two combination. And that is a black shirt and a white skirt and a black shirt and a black skirt. So all in all, Claire has a total of 4 combinations of skirt and shirt that she could wear. Okay? Now, how can we get this answer through fundamental counting principle? And according to fundamental counting principle, it states that when there are n ways to do one thing and m ways to do another thing, then the number of ways to do both those things can be obtained by taking their product. This is expressed as n times n. So to simply put it, we will just simply multiply the number of ways to do those things that we are considering. Okay? And now going back to our example, just to apply fundamental counting principle or FCP. So we will be counting the number of ways or the number of options she has for skirts, and that's 2. The number of options she has for the skirts is also 2. So the number of ways together, combining the shirts and the skirts, is 2 times 2. And that gives us the same answer as what we obtained earlier, which is also 4. So that's the shortcut FCP helps us with. Okay? To further understand FCP, let's try another example. Wendy went to buy an ice cream from a seller who sells 3 different flavors of ice creams. We have vanilla, chocolate, and strawberry. And he gives 6 different choices for cones. How many choices does she have? So what are the things that we want to do at the same time in this problem? So we want to choose from the flavors at the same time from the type of cones. So under the flavors, how many options do we have? We have 1, 2, 3 options. So 3 times under the choices for the cones, we have 6 different choices, and that is 6. So all in all, if we want to do both in this scenario, we'll have a total of 18 possible combinations or outcomes. As easy as that, correct? Let's have another example. Ashton knows there are 7 daily newspapers and 4 weekly magazines published in his town. If he wants to subscribe to 1 daily newspaper and 1 weekly magazine, how many choices does he have? So he is choosing from both newspaper and magazine. So if we combine these two together, or if we want to do both, so we simply multiply the number of options we have for the newspaper, that is 7. And under magazine, we have 4 options. So combining them together, we'll have a total of possible 28 options. And that will be our final answer. But what about this kind of problem? How many 5-digit numbers can be formed using 0 to 9? Still, it's under the idea of FCP. So finding the total number of ways we put the digits all together. And since this is a 5-digit number, so we are considering, or we will be considering 5 places where the digits will be positioned. Now, we want to know how many ways can we have or how many options can we have in each place. So, in the first position, since we are choosing from 0 to 9, so there are 10 options. Second position rather, also 10 options because still we are picking from 0 to 9, and same as well on the other digits. Okay, so if we want to create a 5-digit number, there are 10 times 10 or 10 times 10 times 10 times 10 times 10, which is a total of 100,000. 100,000 combinations. And this will be a lot. If you will do the listing method, this won't be practical to do. So FCP will be helpful in this kind of manner. Now for another twist, let's do the same type of problem, forming 5-digit number, but then again, the twist is without repetition. So if you use 1 digit on the first position or first place, you can no longer use it for the second place, third place, and so on and so forth. So what's the effect of that in our solution? So if we have 0 to 9 as the option in the first position, so that's a total of 10 ways or 10 options. But if the first place is already taken by 1 digit, then that digit can no longer be used for the second position or second place. So this will be lessened by 1. So the options left is only 9. Okay? And same as well for the third position. If the two places were occupied already, then from 0 to 9, it will be lessened by 2 options. So we will have 8 left. And for the fourth position, if these 3 positions are already taken by 3 digits, so 0 to 9 will be decreased by 3 digits. Now, we are only left with 7, so it will be decreased by 1 as we go far to the first position. That gives us 6 options left for the last position, assuming the first 4 are already taken or occupied. So that's the idea of this question without repetition. So we can no longer use what were used in the previous places or slots. Alright, so therefore, we have 10 times 9 times 8 times 7 times 6. That's a total of 30,240 options. 240 options or possible combinations or outcomes. And for our next question, how many ways can you flip 4 coins? So here we are considering 4 coins. So let's say this is my first, second, third, and fourth coin. So we want to know how many options do we have in each event or in each activity. So in the first coin, we have of course 2, having head or tail. Second will also be 2, head or tail. Third coin, 2 also head or tail, and the same goes with the fourth coin. So all in all, if we want to do them all together, flipping 4 coins, we have a total of 2 times 2 times 2 times 2. That is 16 possible combinations or outcomes. So now it's your turn. I want you to answer this problem. The combination for a keypad is 5 digits long. Suppose that you can use any digit 0 to 9 for the numbers. Now, the first digit cannot be 0. How many different combinations are there? So don't forget to comment your answer below so we can check and verify if that's correct. And here's another one for the license plate problem. A license plate has 3 letters followed by 3 numbers. So again, 3 letters, 3 numbers. Those are the positions. Every letter and number must now be unique. How many different license plates are there? So I want you to try, solve this problem, and let's see if you got the correct answer. And that will be all for this video. Thank you so much.